According to a recent census, 17% of the people in the United States are of Hispanic origin. One county supervisor believes her county has a different proportion of Hispanic people than the nation as a whole. She looks at their most recent survey data, which was a random sample of 497 county residents, and found that 45 of those surveyed are of Hispanic origin. Complete parts A through D below. Okay, so we're going to set up the null and alternative hypothesis. So the null is always equals. So that eliminates choice A and D. So now we're just deciding on B or C. So we set the null that P equals 0.17, which is 17%, and the alternative hypothesis, we look for keywords in the statement. So is there a suspicion that it's less than, greater than, or we just don't want to know, is it different? And in fact, in this particular problem, it says she believes has a different proportion. So the different one is the two-tailed test, or C. Okay, name the model and check appropriate conditions for hypothesis test. Okay, so we are looking at comparing one proportion to the population proportion. So this is a one proportion Z test. So in this class, the proportions are always going to be, if you're just looking at one or two proportions, we're going to use the Z test. There's another test you could also use, but for now, this is the first test we're using. So it's easy, one proportion Z. We'll use the t-test in a subsequent lesson when we start looking at means. Here we're looking at proportions. So when you see these proportions pop off as percentages, you're going to think, I'm going to be using a 1-prop or 2-prop z-test most likely. Later on we'll look at something called a chi-square, but for now, 1-prop z-test. Okay, now check the conditions. Now remember the conditions, we need to sort of make sure this came from a random sample, and I believe it says in the problem that there was a random sample of 497 county residents. So random sample. We have to make sure the population isn't too big. The sample isn't too big, it isn't too small. So this text uses a 10% sort of benchmark. So the sample can't be greater than 10% of the population. This is generally not a problem with our sampling, right? And then we have to check that we had at least 10 expected successes and at least 10 expected failures. And this is an actual calculation that we can do, and they've kind of given us here of the 497 residents were random sample from the county of interest, the standard deviation of P less than 0.5 one expects, and it says N times P naught and N times Q naught, which are both more than 10 is what we're looking for, right? Okay, so let's check. We're doing all of these things here. So from a random sample, all these say that less than 10% of the population, and one expects, so it's got to be the C. Now we got to fill in. So N times P naught, so the P naught is that 0.17. So N, which is 497 times 0.17. Whoop, I'm marking actually the wrong one. C. N times, so this was 497 times 0.17. And wants us to round this to 1 decimal place right here. 1 decimal place. You'd hate to miss all that just because of that. If you ever do, just let me know and I can override that very easily. Is 84.5. And then N times Q naught. Remember, Q naught is 1 minus P naught. So 497 times 0.83, right, is 412.5. Hopefully I got that right. Okay. So thus the conditions are met and it is appropriate. Wasn't sure it was going to be in there to use the normal model and perform the hypothesis test. Okay, so we want to sketch and label our normal curve, calculate the test statistic and p-value, and choose the correct sketch below. So I'll be honest, I sometimes have a hard time looking at their graph and trying to think through it. I'm just going to draw my graph out, and then I can compare it a little bit easier. So sketch out the normal curve. And what was our percentage here? 0.17. That was our P naught. And then my percentage, my P hat, was less than 0.17, right? It was like way out here. 0.091. Remember how I found that? P hat was 45 over 497. I'm just finding what proportion did I have? I mean, they say the national average was 17%. Well, what percentage did I have for my sample? That's all we're doing, so don't overthink that. And I get 0.091, which is about 9.1%. Okay, so it's definitely less than that. The question for us is, what's the statistical likelihood of me getting a sample of 0.091 if indeed my population in my county really is 0.17? And I'm going to let the StatCrunch figure this out. Before I do that, let me pick the right one. Let's see, I had 0.17 in the middle. This A is the only one that has that happen, right? And 0.091 was way out here. This vertical line is not the y-axis, which is what I actually thought it was at first when I looked at these. So all they're just pointing, that's what that is right there, which is hard for them to fit that in. Okay? Okay, now I want the test statistic, and now I need to use a statistical software to crunch that out. So go up here to Question Help, StatCrunch. And we could use, and you may have seen this done on one of the videos I've done, the normal calculator to crunch that out. Put the 0.17 in as the mean. You'd actually have to crunch out that standard deviation though, right? Which can be kind of a pain. So let's not use a normal calculator. And let's go ahead and go to Stat. And we're going to go to Proportion Stat. We have one sample, and we just have summary data. This is usually the one we're going to have when doing these. Not all the time, but usually summary data, with proportions in particular. Okay, so number of successes, so which was 45, and our number of observations was 497. That's our N. And we're doing a hypothesis test. And what was our P sub 0? 0.17. And make sure you choose the right alternative. It was not equal to the two-tailed. And we don't need to do these two, so just press compute. And here we go. So there's our proportion. Look at that to make sure it's the same, that we computed that by hand. That was pretty easy. Here's our test statistic. Negative 4.72. Or sorry, 4.72. Let me see what they want me to round to. To two places, which is pretty customary for these statistics. So note here, I'll leave this in. Looks like I missed it. Maybe I misread the output. So let's look at it. But notice what they give. They give you how to do this by hand, and I don't want to do that. So sometimes they're trying to be helpful. Let's give them some credit. They are trying to be helpful here, but we're turning to the technology to crunch these out. And you see what I missed? I missed that negative sign there. It's negative 4.72. So let's pop that in. And that makes sense. It's less than. So my proportion that I got from my sample was certainly less than the mean proportion from the nation. There we go. And now the p-value. Calculate the 3 decimal values as needed. So let's look back over here at the p-value. And it just says less than 0.0001. So that's what we're going to put in there. Or actually, for p-value 0, so 3 decimal places, 0.123. Technically it's a 1, but that would be 4 decimal places. If you put a 1 in there, I'd give you credit. But I'm pretty sure that's what they're wanting. So really, it should be 0. I don't really like that because when you're doing research articles, right, you're not going to put a p-value of 0. you would naturally put less than 0.0001. So it'd be nice if they had a multiple choice option here that allowed you to say that if it was a very small p-value, but they don't. So when in Rome, this is what we got to do. Now our conclusion. So remember what this means. What did we just find out? If you look back at the curve that you drew, or that I drew, we're wanting to know how likely is it that I get a sample this small or more extreme or smaller if indeed our population were 0.17. Remember, this is our null hypothesis. This is kind of tricky to have to put together. How likely is it that I get this 0.091 or more extreme? It's pretty unlikely, 0.0001. So we're going to reject. It's unlikely that my population really is 0.17, because that's a pretty low p-value. So because the p-value is so low, so we know it's down to B and C, there is enough evidence that it's different. See? Okay, so I hope that helps.